Now we're going to take a look at what we have to do if we end up with uncommon denominators, which will happen quite a lot. Just like with simplifying rational expressions, if we need to find a common denominator, the first thing we want to do is factor the denominator completely. Then, this is the fun part. We want to identify all the unique factors, and then the least common denominator will consist of all the unique factors raised to a power equal to the greatest number of times that the factor appears in any single denominator. So let's go ahead and dive right in. We want to go ahead and find the LCD of these rational expressions. However, we're not going to add or subtract. We're just identifying the least common denominator. So the factors in our first denominator are 3, x, and y. We're just identifying the unique factors, not necessarily the exponent yet. Then when we look at our second denominator, x and y are already in our list, but we are going to include the unique factor of 5. Then we want to go through this list and we want to find what is the greatest power that this factor is raised in any of the single denominators. So we start with 3. Well, 3 only shows up in this denominator and it only shows up once, so it's 3 to the first. X shows up in both denominators, but in this denominator it's x to the 5th, so our LCD will have x to the 5th power. Then we look at y. Y, of course, shows up in both, but in this one, it's y to the 3rd power, which is greater than the second. So our LCD will have y to the 3rd. And then lastly, with the 5, it only shows up once in the second denominator, so it's just the 5. Any rational numbers, we can go ahead and multiply those, but our least common denominator will be 15, x to the 5th, y to the 3rd. When we take a look at our next one, we see that we have a binomial in our denominators. Since they can't be factored at all, each of those denominators only contain the factors of z plus 1 as well as z minus 1. So in this case, since both factors are unique and there's no other factors in any of the denominators, then our LCD is the product of those two factors, z plus 1 and z minus 1. For C, we have 3 different terms, so we're going to need to factor and look at all the different factors for each one. Our first is a difference of squares, which factors to be m plus 5, m minus 5. Our second is a trinomial that factors to 2m plus 1 and m minus 5. And our third is a perfect square trinomial that factors to be m minus 5 squared. So we look at our unique factors. Starting with the first term, we have m plus 5 and m minus 5. Then in our second set, the only one that's unique is 2m plus 1. And with our last set, we have m minus 5, which isn't unique and it's already in our list. And then we want to see how many times each of these factors show up within each denominator. m plus 5 only shows up in the first one once, so we leave that at first power. M minus 5 shows up in all 3 of them, but in the third one it has an exponent of 2, so our LCD will include m minus 5 squared. And lastly, 2m plus 1 only shows up once, so we have our LCD now with our proper exponents. M plus 5, m minus 5 squared, and 2m plus 1. Lastly, we'll take a look at factoring these two. We get x plus 2 and x minus 2 for our first denominator. Now our second denominator has a GCF, but notice how our variable is at the end because we're subtracting. So we might want to consider factoring out the negative GCF, which switches the sign. So the GCF of 6 and 3 being 3, if we factor out negative 3, that leaves us with a positive x and a negative 2. And that works out because that's already a factor. That way we're not adding in a new unique factor for our least common denominator. So our unique factors are x plus 2, x minus 2, and the negative 3.